My name is Juan Sanchez and welcome to the wonderful world of mathematics.
So we're talking about circles today. Where did this journey for knowledge start from? Well, actually it started with the Egyptians and Babylonians well over 4,000 years ago into the past. And what they were trying to figure out is, what is this stuff really all about? But, well, actually, to begin to talk about circles, you must first know how to create a circle. So what the Babylonians were trying to do is figure out a certain number that you can multiply this length across the circle, which we call diameter. So a number we can multiply the diameter by that would give us the length around the circle. The circumference, which we call c sometimes in math. So what is the diameter? The diameter is the length from one side of the circle all the way across to the other length of the circle, passing through this point in the center. And the radius is only the distance from the center to the outside of the circle. So if you notice, the radius is actually half the length of the diameter. So if we want to say that mathematically, we can write an equation that says the diameter is twice the length of the radius, or 2r. And actually you can make a lot of math like that. All this is an equation saying something is the same as something else. It's kind of like a metaphor, like a comparison or a synonym. So they figured that, the Babylonians figured that to get the circumference you would need to multiply the diameter by about 3. So what they realized was that when you take the circumference of a circle, so the length all the way around it, and you divide it by a diameter, or the diameter of the circle, you get a number that's always about 3. Now that might look familiar, right? Have you ever heard of pi? Well, this is where pi comes from. So pi is the exact ratio between a circle's circumference and diameter. But what does ratio mean? A ratio is any time you take a number and divide it by another. That's all there is to it, a ratio. So for example, if I take the number 2 and divide it by 5, that's a ratio right there. It's any number that is divided. So pi is the ratio of circumference to diameter. So let's say we multiply this on both sides by diameter. Wait, let me erase this real quick. So we multiply both sides by the diameter. And what happens now? This diameter and this diameter will cancel out, leaving us with circumference is equal to pi times the diameter. But if you see right here, the diameter is the same thing as 2r. We could actually write this again, saying the circumference is, and now instead of writing diameter, we are going to write 2r in there, or it's written mostly as 2 pi r. So pi is approximately 3.14. But 3.14 is not pi, that's just an approximation, that is rounding. Pi, the decimals of it go on forever and ever with no particular pattern, no reason, no rhyme to it. They just go and go and go and go. And there's actually really awesome supercomputers that calculate pi up to 3 trillion digits. And they're still going. So there is no end to pi. But 3.14 is a pretty good approximation of it. So let's talk about area now. What is area? Area is essentially how much you can shade in within that inside a shape. So things like a square, or actually a rectangle, let's say that's the width and that's the length. We can find the area by multiplying the length times the width. A triangle, all we have to do is take the base, multiply times the height, and divide it by 2. Because triangles are essentially just half of rectangles. So you take the length and width, divided by height, divided by 2. Okay, so we take the base times the height, or length times width essentially, and divide it by 2. That's how we find the area of circles. Of triangles. Now, but what about a circle? So a lot of you might know this already. The area of a circle is found by taking pi and you multiply it times your radius squared. And I ask this a lot of people, I go, okay, what is the area of a circle? And you might be able to tell me right off the top of your head because it's something you've been taught in math classes all throughout your life. But the real question is why? Where does that come from? If you don't know where this comes from, all you're doing is plugging in and solving. They'll give you a radius, and you'll solve for the area, or they give you the area and you'll solve for radius. But that's not real math. That's just plugging in and taking care of some little bitty calculations. Let's find out where this really comes from. Okay? So the way we're going to do that is through approximating the area of the circle first. When I ask a lot of people to do this, they usually tell me some weird like reasoning in English, but you can't prove something mathematically through your reasoning and thinking in the English language. We have to prove it with math. So that's what we're going to do. Okay. So we're going to do this all in terms of the radius of the circle, because the radius is what defines the circle. So how about we start, since we have no idea, or let's forget anything you know about circles. Let's assume we have no idea how to find the area of a circle. We can start by approximating. So what if we put this inside of a square that perfectly fits it? My lines aren't perfect, but in your head, using your imagination, that is a perfect circle inside of a perfect square. So how long across is this square going to be? Well, the distance from the center of the circle to the outside is the radius. So since we have a radius here and a radius here, this is actually 2 radiuses, or 2r. And the same for the height. Since this is a square, the length and the width are the same, right? That's a radius and that's a radius as well. So this side is also 2r. And how do we find the area of a square? We multiply the sides times each other. So 2 times 2 is going to give us 4, of course. And r times r is going to give us r squared. That's a great way. Anytime you have variables that you multiply together, just that number is how many of them you have. So we have 2r, so we have an r squared, r times r. But that still leaves us with all this extra space, right? So 4r squared is actually too much. Let's try something else. What if we cut some corners? So now that we've cut off some of the corners, we have an octagon. And if you notice, that's actually a lot closer to the area of the circle than we previously had with the square. But how do we find the area of an octagon? Well, if you ever encounter a shape that you're trying to find the area of and you have no idea how to do it, a great technique is to just split this up into easier shapes. So what if we cut it up into a bunch of triangles? There's a triangle right there. I'm going to erase this radius to avoid any confusion as well. So we have 8 triangles here. Now, do you remember how to find the area of a triangle? Its area is base times height divided by 2. In this particular case, what's our height? The distance from the center of the circle to the outside, which we call radius. So area is going to be radius times, what's our base going to be? Well, our base is going to be the side of the circles. The side of the shape. Sorry, not a circle, but the sides of the octagon. So we'll say radius times side squared, or how about just, since it's base times height, I'll write it in the right order. S times R over 2. We can't forget the dividing by 2 part. The thing is, there's not only one triangle. If we want to estimate the area of everything, there's actually 8 of them. So our area is going to be 8SR over 2. At first glance, you might want to look at this and divide the 8 by 2 and give you 4, but if you do that, you're going to miss the point. Now, what does that 8S represent? Look, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 S's. So that 8S is actually the perimeter. And if we do this, you could cut this triangle, this circle up into as many triangles as you want. The height of the triangle is always going to be the radius. We're always going to divide by 2. The base is always going to be the side of the shape. But this number is going to change. But regardless of that number changing, this thing is always going to be something. It's always going to be the perimeter. But do we have perimeter in circles? Well, we do, but we call it the circumference. If you remember from earlier, the circumference is the length around the circle. The perimeter is the length around any particular shape. We just give it a special name in the circle, the circumference. The circumference is 2 pi r. So if that approaches the perimeter of the circle, or the circumference, then we can actually take this and throw it in here. So let's rewrite that now. Area equals 2 pi r, now instead of 8s, times r over 2. So what's going to happen to those 2's? They're going to cancel out, and pi times r, what do we get when we multiply r times r squared times pi. So now we see that the area of a circle is pi times the radius squared. And this is how it was done way back in the day. Let's give it up to the Greeks. So let's say you own a house and you want a beautiful circular patio in your backyard. That would look really nice. You could have nice little dinner parties and stuff outside. So you've decided, you've mapped it out, you drew yourself your little circle in the grass. And, hey, this is where I want that patio to be. Well, you're obviously going to need some of those like bricks or brick tiles to put in it. So you go to Home Depot, but how many tiles do you need to buy? If you don't know the math, you're either going to buy not enough or you're going to buy too many, which requires a second trip back to Home Depot. So you go to Home Depot, you buy not enough. Oh man, you have to go back and buy some more, hoping that no one else has bought the rest of them yet. And if they did, then you're screwed. You have to go back to your house, pick all your stones up, take them back, and then actually get different stones, and then repeat the process over and over again. If you don't know the math, you could also probably buy too many, which again requires you to drive back to Home Depot or whatever store you get them from and return them. So all that extra driving, all that extra work could be avoided with a simple calculation of figuring out the area, dividing it then by the area of the individual tiles or bricks, and you'll know exactly how many bricks you want. No need to guess. And that's what math is all about, avoiding guessing. We don't need to guess. You don't need to guess when you have math. Now we're going to use calculus to find the area of a circle. If you don't know calculus yet, that's okay. And notice how I said yet, because you should totally go for it. So, calculus. Let's say you don't know calculus, that's okay. Just try to follow along. I'll try to make everything make sense. If you do know calculus, then it'll make even more sense to you now. When I ask people about the area of a circle, a lot of people tell me that the area is actually the integral of the circumference, and therefore it just makes sense. But nothing just makes sense. Everything has to have a reason behind it and an explanation. So here's the explanation. Let's say I want to shade in the circle. How can I shade the circle? And well, if I take a little dot and put it in the center, we can call out a circle with a radius of 0, right? That has no radius, it's just a point. And then I'll put a slightly bigger circle with a slightly bigger radius and circumference around it. And then another one around that, and then another one around that, and so forth and so on. If I put an infinite number of circles in there, the circumference will shade in all of the circles. The circumferences of the smaller circles will shade in the bigger circle inside. So what does that mean mathematically? That means we're going to add up the circumference. So we're going to take the circumferences, which this is the equation of how we find circumference, right? 2 pi r. We're going to take the circumference of every circle and add them all up. And that's what this means. It means we're going to take a sum of circles with a radius of 0, so from there, all the way to a radius of r and dr. That just means that each circle is going to be just a tiny, tiny bit bigger than the previous one. That's what that means. So we're just going to add all these up. And this means integrate this. And what that means is, well, if you remember slope, that's all calculus is about. What this means is that this is the slope of something. So we need to find whatever this is the slope of. And so we take care of some math. It's called the power rule. It lets you know that the integral is pi r squared. So this is the slope of that, and that is the integral of that. So pi times radius squared, and we're going to take it from 0 to r. We have to plug both of those values in and find the difference. So when we plug in r to r, we get pi r squared, and we subtract when we plug in 0. So we're left with 0 there, so all we're left with is area equals pi r squared. And which is great. See, when you're able to prove something with different branches of math, it really shows you that it's true. This is why I believe that is true. Alright, you can't believe it just because your teachers tell you, You can't believe something just because you're told to believe it. You have to know that it's true for yourself. And actually what blows my mind is that for thousands of years this was staring them in the face. But it wasn't until Isaac Newton came along and formulated calculus that we were able to really see this. But I just think that's amazing. It shows you how math through the centuries just stays true. Okay? And if you can prove it wrong, that's great. That's actually what we're looking for. If you can prove anything wrong, then you've shown us the light. Then we can see what the real truth is.
Whoa, would you look at that? I found the formula sheet. Now I know all the secrets of the circle. I should tell the Babylonian and Egyptians about this.
We could also take the SpongeBob approach to drawing a circle by first drawing a beautiful portrait of my friend here who is in love with math. Now, it took a lot of work to create this, so all I'm going to do is now start erasing some of the detailing in it. And erase, erase, erase. And bam! Left with the perfect circle. So thanks for watching. I hope y'all had a wonderful time. Stay tuned. Next time we're going to talk about exponents and some of those exponent rules. So have a good day. And remember, the math is real.